Hello, math analysis students. This video is for page 2 of the review guide for Unit 2, exponential and logarithmic functions. Here we are going to practice solving exponential and logarithmic equations. We should leave our answers as exact values, no decimals. You are allowed to use a calculator on this, but there is no reason that you need to use a calculator. You do not need to get decimal answers. If you get an answer that has a log or a natural log or an e in it, it's okay for us to just leave that answer. So, let's begin. Okay, problem 16. The natural log of 3x plus 5 equals 8. Excuse me. So we need to get our x by itself. It's with this 3x plus 5, so we need to get rid of our natural log. And the way that we get rid of our natural log is by, the inverse of a natural log, which is e. So we want to do e to get rid of that natural log. And I'm putting this in different colors just to show what I am doing differently. And of course, we can do just about anything we want to an equation as long as we do it to both sides. So if we put an e on one side, then we need to put an e on the other side. So now e is the base of these exponents, and we have what was previously our main line is now our exponent. So here, the reason we took e, because it's the inverse of a natural log. Of course, the base of a natural log is e. So we have e as the base of our exponent and the base of our log. They will cancel each other out, and we have 3x plus 5 equals e to the 8th power. Now we just need to get that x by itself, so we need to subtract 5 from both sides. That cancels out here. We get 3x equals e to the 8th minus 5. And then last step to get that x by itself is to divide by 3. And so our answer here is that x equals e to the 8th minus 5, all divided by 3. There is, of course, a decimal value for that, but we're going to leave it an exact answer right here, so we do not need to go to our calculator for that. Number 17. Log of x minus 1 plus log of x minus 2 equals log of 2x plus 8. Well, if there was just one log on the left-hand side and one log on the right-hand side, then we could use our one-to-one property and we could cancel. But we don't have that. So we need to condense this left-hand side first. So notice that we have a plus sign. So when we condense this, that means we're going to multiply these two parts together. So we will have log of x minus 1 times x minus 2 equals log of 2x plus 8. Now we have log of this amount on the left equals log amount of this on the right, and now we can use our one-to-one property and these logs cancel each other out. So now we're left with just an algebra problem. So let's work out this algebra. This x minus 1 times x minus 2, we need to distribute this, so we will get x squared. That's going to be a minus 2x. Here, I'll go ahead and do that. Minus 2x minus 1x plus 2 equals 2x plus 8. I'm going to simplify this out a little bit. X squared minus 3x plus 2 equals 2x plus 8. And then what we have is a quadratic equation. And so we want to get everything on the left-hand side and 0 on the right-hand side, and then we can factor. So we want to subtract 2x. That will cancel that out over here. We want to subtract 8. That will cancel. And we will be left with x squared. We have a negative 3x minus 2x is a negative 5x. And a positive 2 minus 8 gives us a negative 6. And on the right-hand side, we have 0. We need to factor this into two parts, two binomials. Our terms multiplied by x squared, so that's going to be an x and an x. Now, since our leading coefficient here is 1, that's nice and very straightforward. We're just looking for two numbers that multiply together to be this negative 6 and add up to be negative 5. And the only combination of numbers that will add up to be negative 6, multiply to be negative 6 and add up to be negative 5 is a negative 6 and a positive 1. If you try any other combinations, those sign values are not going to be correct. So now we have x minus 6 times x plus 1 equals 0. Set each factor equal to 0. So first we'll set this factor equal to 0, x minus 6 equals 0. And we'll set this factor equal to 0, x plus 1 equals 0. And we'll solve both of those equations. This gives us a value of x equals 6, and this gives us a value of x equals -1. Now, whenever we're working with logs, we should check to make sure that the values are going to actually work in our original expression. When we plug it in, if we would be taking the log of something that's a negative number, then that is bad. So we want to make sure, that whatever we plug in, this part here, or this part here, or this part here, what would be evaluating the log of, is going to be a positive number. If we plug in 6, that works, that's fine. However, let me go back to a regular pen here. That works fine. But if we were to plug in -1 into our original problem, then we would end up taking the log of negative numbers, and the log of negative numbers do not exist. So this right here is an extraneous solution, and we end up with just one solution for this equation, which is x equals 6. We've got a number 18. The log base 4 of 3 plus the log base 4 of x minus 4 equals 2. Well, on the left-hand side, we have both of these are the log base 4. So let's go ahead and condense this expression. We'll get the log base 4 of 3 times x minus 4, using the product property, equals 2. So we're going to want to distribute here. So we'll have the log base 4 of 3x minus 12 equals 2. So we need to get this x by itself. We need to get rid of this log base 4. Well, the inverse of log is an exponent. We can exponentiate and make both of these sides of the equation the exponent. We choose a base that is going to cancel out. Since this is a log base 4, then we want to do 4 as the base of an exponent. And if we choose 4 as the base of an exponent on the left, then we need 4 as the base of an exponent on our right. Now, this 4 is the base of our exponent and this 4 is the base of our log. Cancel each other out. On our left-hand side, we're left with 3x minus 12. And on our right-hand side, we have 4 to the second power, which is 16. Now, this is a simple algebra equation. We will add 12 to both sides. That cancels. We get 3x equals 28. And our last step here would be to divide by 3. And so, x equals 28 over 3. No need to get it as a decimal. If you could simplify that fraction anymore, you would want to, but it does not simplify. We don't need it as a mixed number. We don't need it as a decimal. 28 thirds is a perfectly acceptable answer for this. Number 19. 2 times the log base 6 of 4 minus 1/3 times the log base 6 of 8 equals the log base 6 of x. Well, they all say log base 6, so that's good. We need to do some condensing on our left-hand side. There's a couple things going on here. We have a minus, so we're going to condense using the quotient property. And also, we have some coefficients here, which are going to become some exponents. So, we're going to rewrite this. We're going to have a couple of different things going on. This is going to be the log base 6 of, this is going to become 4 squared. And this will be 8 to the 1/3 power. 1/3 power is asking for the cube root of 8. And since we are condensing with quotient rule, that means we're going to divide. So 8 to the 1/3 power is asking us for the cube root of 8. That's our simplified left side, and our right side is log base 6 of x. So now we have log base 6 of this amount on the left equals log base 6 of this amount on the right, so we can cancel our log base 6's, and now we just simplify what we have left. 4 squared is 4 squared is 16. The cube root of 8 is 2, and on the right-hand side we just have x. Now simplify that. You can tell I got a little bit ahead of myself in my last statement there. 16 divided by 2 is 8, and so our solution to this equation would be x equals 8. Now I forgot to say it last time, but check to make sure that if you're plugging this in, you would be taking logs of positive numbers, not negative numbers. This one does work, so our answer is x equals 8. Number 20. 5 equals 3e to the 4x minus 4. So we need to get this x by itself, so we need to isolate this 3e to the 4x. So first step, let's just do some algebra. Let's add 4 to both sides. That gives us 9 equals 3e to the 4x. Now the simplest thing for us to do here will be to divide by 3. It's not the only thing we could do, but it's definitely the simplest thing. That cancels out here, and 9 divided by 3 gives us 3 equals e to the 4x. I'm going to switch it just because I like to have my variable on the left. E to the 4x equals 3. Now since we're trying to get x by itself and it is in our exponent, we need to get rid of this base e. The inverse of e is natural log. So we're going to take the natural log of both sides. So that's natural log of e to the 4x equals the natural log of 3. Then here our natural log and our e cancel each other out. 4x equals the natural log of 3. And to get x by itself, we'll just divide by 4. And so our final answer will be x equals the natural log of 3 over 4. It does have some decimal value, but we don't need to get that decimal value. It's okay for us to leave our answer like this. Number 21. 9 to the 4x plus 2 times 27 equals 3 to the 2x plus 5. This one looks challenging. Our bases are not the same. 9 and 27 and 3. They are not the same, but if we could write them all with the same base, then that would be something that would help us out. So 9 and 27 are all powers of 3, so let's rewrite these as powers of 3. We're going to rewrite 9 and we're going to rewrite 27 so that they are powers of 3. 9 is 3 squared, so that is 3 squared to the 4x plus 2. And 27 is 3 to the 3rd power. We have that still equals 3 to the 2x plus 5. Now let's use our rules of exponents. Here we have 3 squared to the 4x plus 2, so we'll use our power rule. When we raise a power to a power, we multiply. So this is 3 to the, we'll multiply 2 times 4x plus 2. That gives us 8x plus 4 times 3 to the 3rd power equals 3 to the 2x plus 5. Let's simplify a little bit more on the left-hand side. They have the same base, so we can add those exponents. 8x, we have plus 4, and here we have 3, so they combine to be plus 7, equals 3 to the 2x plus 5. Now we'll use our one-to-one property. They both have a base of 3, and they're on different sides of the equation, so they cancel each other out. And now we have a pretty straightforward algebra problem to solve. 8x plus 7 equals 2x plus 5. We want to get our variables on one side, we want to get our constants on the other. If we subtract 2x from both sides, that's going to give us 6x over here. If we subtract 7, that's going to give us equals a negative 2. And we're going to divide by 6. And that will give us an answer of x equals negative 1/3. Now, can we have a negative answer? We need to make sure that what we'd be evaluating is okay. If we would plug it in and we would be evaluating the log of a negative number, then that would be a problem. But since this is, if we plug it in, we're not evaluating any logs here, we can raise numbers to negative exponents, and that's perfectly fine. So our answer here is x equals negative 1/3. Okay, number 22. 3 to the 2x equals 7. Okay, we have 2x in our exponent, so we need to get rid of this 3 that is the base of our exponent. So what do we want to do here? I'm just going to rewrite that with a little bit of space here. And if we want to get rid of this 3 that's the base of our exponent, then the inverse of that is take the log base 3. We choose base 3 so that these will cancel out. If we do that to the left, then we need to do this to the right. I'm going to give myself just a little bit more space there. Log base 3 of 7. So then our 3 is the base of our log and 3 is the base of our exponent, cancel each other out. What we're left with now is 2x equals the log base 3 of 7. And to get x by itself, we'll divide by 2. So x equals the log base 3 of 7 divided by 2. There is a decimal value for that. We do not need to do anything else. That is a simplified answer. Number 23. 2 times the natural log of x plus 2 minus the natural log of x equals the natural log of x plus 6. Okay, there's several things going on here. We do have a coefficient, which is going to come up here as an exponent, and we do have a minus sign. We're going to condense this using our quotient rule. So this is going to become the natural log of, okay, we're going to have the quantity x plus 2 squared over this x equals the natural log of x plus 6. So we've condensed our left-hand side, and now we have just the natural log equals the natural log, so we can cancel those out, and now we're left with just the algebra. So on the top, when we multiply x plus 2, that quantity squared, we will get x squared. Students mess up on this a lot, so let's go ahead and write this out. When we do all of this, remember that you need to multiply all of your parts. So we'll end up with x squared plus 4x plus 4 divided by x equals x plus 6. Okay, this top we can't factor out an x out of everything, so we don't want to do that. What we want to do to get rid of this divide by x is multiply by x. If we multiply by x on the left-hand side, then we need to multiply by x on the right-hand side. Sorry, I did not mean to look like that was crossing out. Let me try that again. I was trying to write a parentheses. We're going to multiply this side by x as well. The reason for that is that now this x and this x cancel each other out. Our left-hand side is just our numerator of our fraction, x squared plus 4x plus 4. And on our right-hand side, when we distribute, we'll get x squared plus 6x. So we have x squareds again. So get them on the same side of the equation. What happens when we subtract x squared is that they cancel each other out. Then we have 4x plus 4 equals 6x. Let's get our x's on the same side. We'll subtract. That gives us 4 equals 6x minus 4x is 2x. And to get our x by itself, we'll divide by 2. And we get our final answer of x equals 4 over 2, which is 2. And our last problem here in this section, log base 2 of 3x minus 4 equals log base 2 of 2x minus 7. It looks like it's pretty straightforward. We have a log base 2 on the left and a log base 2 on the right, so they cancel each other out. Nice. We have 3x minus 4 equals 2x minus 7. It's a pretty simple algebra equation to solve. Let's get our x's on one side and our constants on the other. We subtract 2x from both sides, then that's going to give us an x minus 4 equals a negative 7. And we'll add 4 to both sides. And we will get x equals negative 3. But since this is a log problem, we want to make sure that we're going to be working with positive numbers. If we were to plug in negative 3 into our original problem, then we would have negative numbers, and we cannot take the log of a negative number. The log of a negative number does not exist. So that means that this is an extraneous solution. So what is our actual solution to this problem? There are no solutions to this problem. The only one that works for this algebra problem right here is a value of negative 3. But that negative 3, even though it works for this algebra problem, does not work in our original log problem. And so there is no solution. Make sure to practice, and good luck on the test.